On this RAM 1500 Classic with the 3.6 Pentastar, P0073 means the PCM is seeing the ambient air temperature sensor signal high. In plain terms, the outside air temperature input may look open or pulled high to the controller. The MIL may come on, the outside temperature reading may be wrong, and strategies that use outside temperature information may act differently. The broad areas to keep in mind are the sensor connector, the signal circuit, the sensor return or ground side, and the module input. This is a two-wire temperature sensor circuit built around a 5.0 reference signal. As a general guide, above approximately 4.9 volts would set a circuit high or open fault, and below approximately 0.10 volts will set a circuit low fault. In the fault criteria, the low side is typically in the 0.1 volt range, and the high side is typically in the 4.9 volt range. Start with the basic system checks. Look for any applicable bulletins, star online cases, or ECU flash updates for the code or symptom. Then check for battery voltage codes, because low battery voltage can set faults. From there, handle circuit faults before chasing rationality or performance behavior. Before unplugging anything, make sure the ambient temperature sensor connector is fully seated and locked. Depending on build and configuration, the sensor may be in the front grille area or in either mirror housing, so make sure you are testing the correct part of the circuit for the vehicle in front of you. Also remember that circuit high and circuit low faults can be monitored by more than one module, but the PCM is the one that performs the rationality check on the ambient air temperature signal. After that initial lock connector check, disconnect the component connector and look for water intrusion, pushed out terminals, damage, corrosion, burnt terminals, or spread terminals. Record all codes and captured data, save a vehicle scan report, and review the captured operating conditions and the setting conditions. For the performance side of this sensor family, the monitor may be looking after an 8-hour cold soak with ambient air, intake air, and engine coolant temperature values above -64 degrees C, -83 degrees F. And the irrationality check is typically not within 10 degrees C, 15 degrees C, 18 degrees F, 27 degrees F of the other engine temp sensors. Then erase the codes and operate the vehicle or system under similar conditions. If the code or condition comes back, continue testing. If it does not, treat it like an intermittent and try to duplicate the captured conditions instead of guessing. For an intermittent P0073, verify the failure mode is actually present before going deep into circuit testing. Recheck related flash updates and bulletins, then work the harness. Wiggle test any harness the ambient temperature sensor circuit passes through while watching for the fault to go active or for scan data to change. Check battery charge, battery connections, related chassis grounds, module connectors, component connectors, and any inline connectors for terminals that are loose, dirty, corroded, burnt, spread, pushed out, or broken. If you have the MAPAR scope available, back probe the temp sensor signal circuit and monitor voltage while wiggle testing the harness. If you cannot watch the signal live, set a trigger to catch an intermittent circuit high fault above 4.9 volts or a circuit low fault below 0.1 volts. The cleanest complete circuit check is with the electrical test lead kit. Connect kit, electrical test lead 2,064,100,081 to the temp signal and sensor ground circuits at the temp sensor harness connector. Move the switch between open and closed while watching the scan tool. For a circuit high fault, the high fault should set in the open position. In the closed position, the circuit should respond low. If sensor voltage is available on the scan tool, expect 5.0 volts when switched to the open position and 0.0 volts when switched to the closed position. Then move the switch to adjust and vary resistance while watching ECU signal voltage. If the ECU and circuits respond correctly, the wiring and ECU are testing good, and the issue points back toward the sensor or a poor connection at the sensor connector. If the signal is stuck high, or only the high fault sets, think open or very high resistance in the temp sensor signal circuit or the temp sensor ground circuit. If voltage is still present when the tool is closed, move the ground side test lead to a known good chassis ground. If the voltage drops to 0 volts, the resistance is on the sensor ground side. If voltage is still present, the resistance is on the signal side. When checking the circuit resistance in this path, it should typically be less than 3.0 ohms. There are multiple test methods here, so pick the method that fits access, tooling, and the failure mode. You do not need to run every method if one complete path proves the circuit. If you are using a DVOM instead of the test lead kit, first verify the temp sensor and ECU connectors are connected and locked. Turn the ignition on, back probe the temp sensor signal circuit at the temp sensor connector, and compare the meter reading to what the scan tool is reporting. A reading between 0, 1, and 4.9 volts is most likely a legitimate sensor signal. If the circuit fault is active and the scan tool voltage does not match the DVOM voltage, the ECU is suspect. A constant voltage above 6.0 volts points to the signal circuit shorted to another voltage supply. A constant 5.0 volts points to an open farther downstream, most likely at the sensor or the sensor ground side. When directed by the voltage test result, disconnect the temp sensor and ECU harness connectors and check the temp sensor signal circuit for high resistance and short to ground. If the signal circuit checks good, inspect every connector in the path before making the ECU the call. To check the temp sensor side, move the test lead over and back, probe the temp sensor ground circuit at the temp sensor harness connector. For the circuit low isolation branch in this same circuit family, disconnect the temp sensor harness connector while watching for the circuit high fault to become active on the scan tool. That quickly eliminates the temp sensor as a possible cause with an active circuit low fault. If the circuit high fault does not become active, disconnect the ECU harness connector to isolate the circuit. Then check the temp signal circuit for continuity to both chassis ground and the sensor ground circuit. Now, for the typical circuit high branch, disconnect the temp sensor harness connector and measure the temp sensor signal circuit voltage with the ignition on. The signal circuit voltage should be between 4.9 and 5.6 volts. With the fault active, jumper across the terminals and watch the scan tool. The temp sensor signal voltage should typically change to 0 volts with the jumper in place, or the circuit low fault should set with the jumper in place. If that happens, the sensor is faulty. If it does not happen, check the temp sensor signal circuit and temp sensor ground circuit resistance. Circuit resistance should typically be less than 5.0 ohms. If either circuit is open or high resistance, repair that circuit. If the circuits test good and the signal is still high, inspect every connector in the path before condemning the ECU. For performance, rationality, or intermittent work, disconnect the temp sensor harness connector and connect the electrical test kit leads to the temp sensor harness connector. Move the switch to open. The signal should read 5.0 volts and a circuit high fault should be active or pending on the scan tool. Then flip the switch closed. The signal should read 0 volts and a circuit low fault should be active or pending. If there is voltage present between 0 and 5.0 volts with the test tool in the closed position, move the ground side lead to a good chassis ground to find which side has resistance. Then isolate that suspect circuit and measure resistance between the sensor and ECU harness connectors. If no resistance is measured, go back through the connector path and look closely for spread, dirty, or corroded terminals. If temperature resistance data is available, use it. The actual resistance can vary +/10% from the values in the data. The chart points include -40 degrees C, -40 degrees F at 345, 26 k ohms as the lowest possible temperature reading, -10 degrees C, 14 degrees F at 53, 38 k ohms as a logical temperature value, -5 degrees C, 23 degrees F at 40, 89 k ohms, 0 degrees C, 32 degrees F at 31, 56 k ohms, 5 degrees C, 41 degrees F at 24, 55 k ohms, 10 degrees C, 50 degrees F at 19, 24 k ohms, 15 degrees C, 59 degrees F at 15, 22 k ohms, 20 degrees C 68 degrees F at 12. 13K ohms, 25 degrees C 77 degrees F at 9,720 ohms. 30 degrees C 86 degrees F at 7,780 ohms. 35 degrees C 95 degrees F at 6,370 ohms. 40 degrees C 104 degrees F at 5,200 ohms, and 150 degrees C 302 degrees F at 181 ohms as the highest possible temperature reading. Set the tool to a resistance value that matches the temperature data. Connect both leads to the temp sensor harness connector with the ignition on, and monitor scan tool temperature or voltage while varying resistance. If the reading matches the data, the temp sensor is likely faulty. If you can acquire or reasonably estimate actual ambient temperature, measure resistance across the sensor terminals and compare it to the data. If the sensor resistance is not in range, the temp sensor is likely faulty. If no temperature data is available, connect the test kit to the harness connector, switch to adjust, and slowly change resistance with the ignition on. The scan tool temperature or voltage should change as resistance changes. To verify an ECU failure, open and short the circuits and monitor both signal voltage and fault behavior. If the expected voltage changes or faults do not occur, and the circuits are not shorted or open, the ECU is indicated as faulty. Before condemning the ECU, carefully inspect all connectors in the circuit path for water intrusion, spread terminals, pushed-out terminals, burnt terminals, or corrosion. Also remember the ambient air temperature sensor is individually serviceable. If measured sensor resistance does not match the temperature resistance data, the sensor is the serviceable part, not the entire mirror assembly. Keep verification separate from the testing. If wiring was repaired, the sensor was replaced, or the BCM connector was disconnected while correcting an active fault, drive the vehicle for a minimum of 5 minutes above 15 mph so the ambient temperature signal updates before the code can move stored and be erased. Then clear the code, reproduce the operating conditions, and confirm P0073 stays gone. The takeaway is simple. Prove the connector first, simulate the sensor before blaming parts, isolate high resistance or opens in the signal and ground circuits, and only condemn the ECU after the circuit and connector path is clean. For more diagnostic training, visit stepdiagnostics.com.